Welcome back. This is video number 6. Section 32. Climate Change Uncertainty, Skepticism, and Denial. In this course, we have used a little science and math to assess the plausibility of atmospheric carbon dioxide emitted by humans raising the temperature of the Earth due to the greenhouse effect, radiative forcing. I see no reason to outright deny the aspects of climate science and climate change that we confirmed in our simplistic way. However, we also saw that many issues are complicated, and we laymen cannot reasonably understand the subtleties and complications, the complicated models, and the many assumptions and approximations. I see no basis to deny that the global average temperature has increased significantly in recent decades, that it correlates with atmospheric carbon dioxide, but correlation is not proof of causation, that increased concentration of carbon dioxide and methane in the atmosphere produces greenhouse effect heating, and that the consensus among climate scientists is that the heating is caused by increased carbon dioxide and methane. Though the consensus is not unanimous and there are uncertainties. But we saw some issues that are significantly uncertain or even unknown, and some amount of skepticism seems reasonable. We can call it being open-minded or aware if the word skepticism is loaded. If climate scientists don't know, we laymen can't know. Climate science uncertainties. Uncertainty of the amount of sulfate aerosols in the atmosphere, and therefore the amount of its cooling effect. Uncertainty in the radiative forcing component amounts for carbon dioxide, methane, ozone, and aerosols. Aerosols allow smaller water droplets to form than would form in the absence of aerosols. This changes clouds and water vapor's feedback effect. This is called the indirect cooling by aerosols, and the effect has considerable uncertainty. There is considerable uncertainty in how much aerosols get emitted by the oceans. Climate sensitivity is said to be 1.5 to 4.5 degrees Celsius, 2.7 to 8 degrees Fahrenheit, per doubling of carbon dioxide concentration, with feedback effects due to water vapor and different types of clouds at different altitudes. This is considerable uncertainty in net amplification. Furthermore, denialists claim the number should be 1 degree Celsius or less. Using the climate sensitivity and present 420 parts per million carbon dioxide, we should get an eventual temperature increase of 0.9 to 2.6 degrees Celsius over pre-industrial temperature. But we have already had a 1 degree Celsius rise, so the low end of the climate sensitivity range seems suspect to me. There is uncertainty for the carbon dioxide removal rates by forests and cold regions of the ocean. Sources say that it takes hundreds of years to 1,000 years for nature to remove carbon dioxide from the atmosphere, but these numbers might not be the time constant, and I cannot find a good number and source. But one source says that 50% of a pulse emission of carbon dioxide is removed from the atmosphere within 37 years, while 22% of the emission effectively remains indefinitely. Seemingly an unusual process if true. There is uncertainty whether methane emissions by wetlands and decomposition of landfill wastes exceeds natural gas leaks and emissions from agriculture, and uncertainty over the amount of natural gas leaks. There were some issues for which I did not find an authoritative number, but I can't say whether this is an area of uncertainty. The time constant or uptake rate for removal of carbon dioxide from the atmosphere by cold regions of the ocean and plants, mainly trees. Uptake may be more complicated than a single time constant and may change with warming and land use changes. I could not verify Earth's energy imbalance, EEI, and whether a difference in radiative forcing between two times should equal the difference in EEI between those times. Climate scientists really don't want carbon dioxide concentration to reach 800 parts per million in the future, as this could blow through dangerous tipping points. I don't know whether these tipping points are well understood and characterized or not. If it were simple and inexpensive to mitigate climate change, it certainly is not. It would still be contentious because the science, modeling, and predictions are complicated and not transparent. We might doubt the science and scientists. If we generally trust science, we don't know whether the models are correct or what unverified assumptions are built in. Maybe the models are wrong. Some denialists say that all climate science is politically motivated, not science. Climate sensitivity is significantly uncertain because the net amplification of water vapor and clouds is uncertain. Increased temperature increases the amount of water vapor in the atmosphere, which mostly adds to greenhouse warming. But if the water vapor increases the amount of cumulus and stratus clouds in the lower atmosphere, they have a cooling effect. I believe cloud size is smaller than the grid size for regional and global climate modeling. Climate scientists use a hierarchy of models. We laymen cannot assess these models. Treating the entire Earth as an average is insufficient. Treating each latitude as a uniform ring is also insufficient, because most latitudes have both continents and oceans. The lower atmosphere has convection, evaporation, clouds, precipitation, jet streams, and hurricanes. Earth's albedo changes with global warming. Global temperature correlates strongly with water vapor concentration in the atmosphere. Climate scientists say that temperature drives water vapor concentration. One contrary article claims that water vapor concentration drives temperature and carbon dioxide is not responsible for global warming. I think this is probably incorrect, and the author confuses correlation with causation or effect with cause, but you may wish to read for yourself. There are issues which climate scientists may understand well but are complicated to communicate to us laymen and policymakers. The fact that it takes hundreds of years to reach steady state temperature for a past change in carbon dioxide concentration and then constant concentration is a real challenge for communicating urgency to the public, voters, politicians, and policymakers. We may acknowledge that temperature has increased and believe that it is due to past emissions of carbon dioxide and methane, but it is difficult to internalize that temperature will continue to rise for hundreds of years due to past emissions. That is just a challenge for our understanding and belief, It is somewhat akin to the frog in boiling water story or moral. Therefore, it is an issue for skepticism or denial. When we still have cold periods during winter, this naturally undermines our belief in global warming, even if cold periods are short and we remember that summer was hot and long. We make cognitive errors, and this is a complicated, confusing issue. Renaming global warming to climate change was a useful change in communications. Sea level rise is difficult to communicate effectively as a number. Telling us the drastic range of worst-case results is ineffective and self-defeating communication when the actual rise is 0.2 meters over decades. More effective is to show us extreme storm surge events. Predictions for year 2100 or 2050 are necessary for planning purposes, but we average people are persuaded by here and now. We perceive weather, but climate change and global warming are harder to perceive and to credit. It is very difficult for us laymen to really understand and feel urgency for a future global temperature increase of 0.5 degrees Celsius. Even if we understand that it will be higher on land than sea and higher in the Arctic. In contrast, we laymen do perceive the high difficulty and cost of eliminating gas automobiles, diesel trucks, and coal-fired power plants. These issues are contentious and polarizing and have been made political. We laymen do not perceive thermal radiation by the Earth, except from hot streets and driveways on hot, sunny summer days. We do not perceive carbon dioxide in the atmosphere. If we accept that invisible carbon dioxide absorbs Earth's thermal radiation and re-radiates some back to the ground, we can't feel it. We accept what scientists say on this, but do we accept that we have caused and are causing a hotter, fragile existence for the next generation? There is much more carbon stored in oceans and the land than we are emitting, so why are our emissions a big deal? Because we are emitting much more than the ocean is releasing. Natural gas leaks are a smaller source of methane emission than wetlands plus decomposition of landfill waste. So, why should we spend a lot of money to find and fix gas leaks? Because reducing methane emissions may lead to concentration declining over time. Methane's perturbation lifetime and global warming potential are complicated and very difficult for us laymen to understand and believe. Following are the main climate change denial claims. We have looked at some of these as issues, but our efforts don't constitute proof. I'm not going to rebut this list, but let you consider the items with the information you have learned in this course. Climate change denial claims include: the climate has changed before, and so the current changes are not human-caused. Increased temperature is due to the sun. Increased temperature is not bad. Carbon dioxide concentration has been higher in the past, and so is not a problem. There is no consensus on climate change. Temperature is cooling. Models are unreliable. The temperature record is unreliable. Animals and plants can adapt and will not go extinct. It hasn't warmed since 1998. Antarctica is gaining ice. Here is a website that gives some rebuttal to denial claims. If we laymen and policymakers believe climate scientists and climate change, mitigating climate change is not at all simple or inexpensive. Reducing carbon dioxide and methane emissions is complicated, expensive, and inconvenient. The coal, oil, and natural gas industries and workers don't want to lose their incomes, but no industry company or worker wants to lose their income or job. No country wants to hurt its production or growth. People don't want their costs to increase. We've added wind and solar electric power generation, but still burn coal and natural gas. We still use internal combustion cars and trucks. Electric vehicles get charged from the grid, which burns fossil fuels. We like to drive. We like to fly. We like packages to be delivered to our homes. We have oil and gas furnaces and gas kitchen ranges. We won't give up our quality of living, and we don't want costs to increase. Climate change and global warming are strongly polarizing issues and strongly political. In this course, we verified or found plausible a number of global warming factors. However, some cases were too complicated for our simplistic calculations. We now have some information and tools with which to examine search results, Wikipedia articles, and other websites and published articles. One place to start is the Intergovernmental Panel on Climate Change, IPCC, Summary for Policymakers, SPM, reports. The first link is the latest version, 2024, but I found the previous version here a little easier to read. Also useful is the MIT Climate Portal. A good forum for asking questions is the subreddit Climate Change. You may come across articles by W.A. Van Wijngaarden and W. Happer. Their articles seem well written and seem authoritative, concluding that climate change is much weaker than climate scientists claim, and the world should expend no effort and cost to reduce emissions. I have not found climate scientist rebuttals to these articles, but perhaps you will. I expect that career climate scientists find such denialist articles perhaps too contemptible to rebut. I have not found significant errors in the articles, but some cases are omitted and their conclusions seem exaggerated to me. But you make up your own mind. To me, as a non-scientist layman, the only aspect of climate change for which skepticism may be warranted is the most difficult question. How much surface heating can be averted in the future? By how much reduction in carbon dioxide and methane emission? Fully taking into account clouds, aerosols, melting of glaciers, thinning of Arctic ice pack, thawing of permafrost, Antarctica thermal inversion, change to the Gulf Stream, jet stream, etc. It's complicated. Section 33, Climate Denial Article and Exercise. If you have followed the science and math in this course, I would like to challenge you with an exercise. I want you to carefully read a particular denialist article and try to find any exaggerations or unstated assumptions. The article is intended to persuade people, and it may persuade you. I would like you to write down before and after reading the article whether you believe in climate change, deny it, or some rating of your skepticism. Afterwards, I will challenge you to work through one additional calculation not included in the paper and see how that changes your assessment of the paper. This 2024 non-mainstream paper says what denialists want to hear, that reducing carbon dioxide emission to zero by 2050 will have very little impact on the temperature in 2050 versus continuing existing emissions, and even less impact if only the United States reduces emissions. The article concludes that the immense costs and sacrifices of such policies to reduce emissions would be all pain and no gain. The article asks an important question: how much temperature increase can be averted by how much costly reduction in emission? But is the paper correct and complete? If you will do this exercise, please pause the video now and read this article critically and try to find any errors, exaggerations, or unstated assumptions. Welcome back. To laymen such as me, this article seems well written and authoritative or definitive on an important matter, perhaps the end to the climate change hoax. It was published by professors from prestigious universities. I found no fault with the equations, data, or calculations, though I think the tone and conclusion are strongly biased, and the article intentionally omits an important result. I would encourage you to do the following. Use the approach of the final section to do a new calculation. How much temperature increase in 2100 would be averted by the entire world reducing carbon dioxide emissions to zero by 2050? Pause the video before I give my answer. I get 1.65 degrees Celsius. Does this missing information change how you feel about the article, its conclusion, and its tone? Sometimes articles need to be read carefully and critically, though this takes effort and we laymen are not experts. I am not a climate scientist or a scientist at all, and I could have made foolish mistakes or failed to understand subtle but critical issues. I hope this course has given you useful information. The next videos cover methane, which is more complicated than carbon dioxide. My other videos on YouTube are various physics courses.